Hello there. Thanks for joining us today. I have been looking over your resume, and it looks like you have a solid 4 years of experience with Angular. We are looking for someone who can not only write clean code, but also help us guide some of our junior developers and help us refine our architecture. To start things off, maybe we can just dive into some of the fundamentals to get a feel for your perspective.
Thank you for having me. I am really excited about the opportunity. I have spent the last few years working on a variety of enterprise-scale projects, and I have reached a point where I really enjoy the architectural side of things, optimizing performance and setting up patterns that the rest of the team can follow. I am looking forward to the conversation.
That sounds great. Let's start with something a bit basic just to warm up. I sometimes see older projects or documentation mentioning ngApp, while in every modern project we use RouterModule.forRoot. Can you explain the difference between those two for me?
Sure, it is actually a bit of a generational gap in the framework. The ngApp directive is from the AngularJS era, which was version 1. Back then, ngApp was used to tell the browser exactly where the root of the Angular application started in the HTML. It basically bootstrapped the entire app from a directive in the DOM.
And then we moved to the modern versions.
Exactly. From version 2 onwards, we moved to a component-based architecture. That is where RouterModule.forRoot comes in. Instead of a directive in the HTML, we now use this method in our module configuration to set up the routing system. It tells the Angular framework which routes to use, and whether it should create a separate service for routing to manage navigation across different views. So one was about bootstrapping the whole app, and the other is specifically about configuring the navigation logic for a modern, component-based app.
That makes sense. Speaking of modern Angular, data flow is a huge part of it. If you have a parent component and you need to get some data down into a child component, how do you typically handle that?
For that specific scenario, the standard approach is using the input decorator. In the child component, I define a property and mark it with that input. This essentially tells Angular that this property is open to receiving a value from the parent. Then, in the parent component's template, I use the square bracket syntax to bind a value to that property. This establishes a one-way data flow, which is the preferred pattern in Angular because it makes the data flow predictable.
Right. But in a larger project, you can't just keep passing data down through 5 layers of children. That becomes a nightmare. Why is it generally better practice to use services or events rather than just direct property access or deep nesting of inputs?
You are absolutely right. That is where prop drilling becomes a real problem. The main reason to move towards services or events is decoupling. When you use direct property access or pass data through multiple layers, you create tight coupling. It means a parent component has to know way too much about the internal structure of its children, and a change in one component can easily break another several levels down.
Which makes the code fragile.
Exactly. By using a service for shared state or events for communication, the components remain independent. They don't need to know who is providing the data or who is consuming it. They just interact with the service. This follows the single responsibility principle. It makes the application much easier to test because I can mock a service easily, and it makes the whole system more scalable. If I need to move a component to a different part of the app, I don't have to rewrite a chain of inputs and outputs.
That leads nicely into my next question. When would you choose an output decorator versus moving that logic into a dedicated service?
I usually follow a simple rule of thumb based on the relationship between the components. If the communication is happening between a direct parent and its immediate child, I stick with an output. It is perfect for simple events, like a child button being clicked or a form being submitted, where the child just needs to notify the parent that something happened.
And when is that not enough?
As soon as the components aren't directly related, I switch to a service. For example, if two sibling components need to talk to each other, or if a component in the header needs to update a component in the footer, using a service is the only sane way to do it. Services also provide a single source of truth. If multiple components need to synchronize the same piece of data in real time, a service ensures they are all looking at the same value, avoiding the complexity of bubbling events through many layers of the component tree.
Let's shift gears a bit and talk about RxJS, since that is such a core part of the Angular experience. You'll often see different types of subjects used in services. Can you explain the difference between a subject, a behavior subject, and a replay subject?
Sure, I like to use analogies for these because it makes it easier to explain to junior developers. I think of a standard subject as a basic radio broadcast. If you are tuned in when the song plays, you hear it. But if you turn the radio on after the song has finished, you missed it. There is no memory of previous emissions.
Okay, and the behavior subject?
A behavior subject is different because it requires an initial value, and it always remembers the very last piece of data emitted. When a new listener subscribes, they don't have to wait for the next event. They immediately receive the current value. This is why behavior subjects are almost always the go-to for state management in services, because the component needs to know the current state the moment it loads.
And where does the replay subject fit in? CANDATE, the replay subject is like a DVR. It is a hybrid that can remember a specific number of past values. While a behavior subject only remembers the last one, a replay subject can be configured to replay the last 5, 10, or even all emissions to any new subscriber, regardless of when they joined. It is incredibly useful for logging or for scenarios where the sequence of events is just as important as the current value. That's a great explanation. Now, since you're talking about subscriptions, we have to talk about memory leaks. You've probably dealt with these in your 4 years of experience. What is the role of the onDestroy hook, and when should it be implemented?
The onDestroy hook is a lifecycle method that runs just before Angular removes a component from the DOM. Its primary role is cleanup. You should implement it whenever your component has active subscriptions to observables, timers, or manual event listeners. If you don't clean these up, the subscription keeps running in the background even after the component is gone.
And that's where the memory leak comes from.
Exactly. The application keeps consuming resources, and worse, the subscription might try to update a component that no longer exists, which leads to those confusing errors in the console. It is essentially a way to tell the browser, "I'm done with this component, you can reclaim the memory now."
If you were reviewing a junior developer's code and you saw several observables that weren't being cleaned up, what would you suggest as the standard best practice for cleanup?
I'd suggest a few options depending on the case. For a single subscription, calling unsubscribe in ngOnDestroy is fine. But for a professional, scalable approach, especially when a component has many subscriptions, I always recommend using a subject combined with the takeUntil operator.
Can you walk me through how that works?
Sure. I create a private subject in the component, often called destroy dollar or stop dollar. Then, in the ngOnDestroy hook, I call next and complete on that subject. For every observable subscription in the component, I add a pipe with the takeUntil this destroy dollar operator. This tells the observable to automatically complete and unsubscribe as soon as the destroy dollar subject emits. It is much cleaner than maintaining 5 or 6 different subscription variables and calling unsubscribe on each one individually.
I've also seen the async pipe used for this. Where does that fit into the cleanup strategy?
The async pipe is actually the gold standard if you can use it. It handles the subscription and unsubscription automatically in the template. If you can pipe your data directly to the view using the async pipe, you don't even need to manually subscribe in the TypeScript file, which removes the risk of forgetting to unsubscribe entirely. I always tell my team to prefer the async pipe first, and only use the take-until pattern when they need to perform logic in the TypeScript code before the data reaches the template.
Let's talk about the tooling for a moment. What is the primary role of the Angular CLI in a professional workflow?
The CLI is essentially the automation engine for the development lifecycle. Its primary role is to standardize how we build apps. Instead of every developer having their own folder structure or manually configuring Webpack and TypeScript, the CLI provides a consistent way to create projects, generate components, services, and guards, and build the app for production. It ensures that whether I'm working on a project or a teammate is working on it, the environment and the build process are identical.
Speaking of professional workflows, let's talk about API calls. Can you explain the relationship between an HTTP client interceptor and your API calls?
An interceptor acts as a middleman. When you use the HTTP client service to make a request, that request doesn't go straight to the server. It passes through a chain of interceptors. This allows you to modify the request on the fly. For example, the most common use case is adding an authentication token to the headers. Instead of adding the token to every single service call in the app, you do it once in an interceptor.
Does it work the other way too? For the responses?
Yes, it does. When the server sends a response back, the interceptor catches it first. This is incredibly useful for global error handling. If the server returns a 401 unauthorized, the interceptor can catch that globally and redirect the user to the login page, without the individual component even knowing the error happened. It separates these cross-cutting concerns from the actual business logic of the components.
Let's move into some more complex scenarios. Imagine you are building a complex form. You have a field where the validation depends on the values of two other fields. How would you structure that logic using reactive forms?
That is a classic cross-field validation problem. In a reactive form, the mistake people often make is trying to put the validator on the individual form control. But a control validator only knows about its own value. To solve this, I would apply a custom validator to the parent form group instead.
Because the group has access to all its children.
Exactly. By placing the validator at the group level, the validation function receives the entire group as an input. I can then pull the values from the two other fields, compare them, and decide if the form is valid. If the validation fails, I can either set an error on the group itself, or, for a better user experience, use the setErrors method to manually push the error onto the specific dependent field so the user sees the red highlight and the error message, exactly where the problem is.
That sounds like a robust way to handle it. Let's go back to the basics for a moment to make sure we cover the foundations. What are observables exactly, and why do we prefer them over standard JavaScript promises in the context of Angular?
Observables are a way to handle asynchronous data streams, powered by the RxJS library. The fundamental difference is that a promise is a one-time deal. It handles a single event and then it's done. An observable, however, can emit multiple values over time.
Can you give an example of where that multiple value stream is necessary?
A great example is a search as you type input. With a promise, you just get one response. With an observable, you have a stream of keystrokes. You can then use operators like debounce time to wait until the user stops typing, or switch map to cancel the previous API request if a new one starts. This level of control, the ability to filter, transform, and cancel requests, is why observables are so much more powerful than promises for complex UI interactions.
You mentioned operators. Let's talk about directives. Can you explain the difference between a structural directive and an attribute directive?
The main difference is whether they change the structure of the DOM or just the appearance of an element. A structural directive completely changes the layout. It adds, removes, or replaces elements in the DOM. You can always tell them apart because they start with an asterisk, like *ng if or ng for.
And attribute directives.
Attribute directives just change the look or behavior of an element that is already there. They don't add or remove anything from the HTML tree. For example, if I create a directive that changes the background color of an element when a user hovers over it, that is an attribute directive. It's modifying a property of the existing element, not altering the structure of the page.
Let's talk about ngIf specifically. Why is it better to use ngIf than simply hiding an element with CSS, like using display none?
Performance and security. When you use CSS to hide an element, the element is still there in the DOM. It is still being tracked by Angular, and its lifecycle hooks are still active. With ngIf, Angular completely removes the element from the document. This means the component is destroyed, and its resources are freed up. When the condition becomes true again, Angular recreates the component. This ensures that we aren't wasting memory on elements that aren't currently needed.
I want to touch on state management. In a large-scale application, how do you handle complex asynchronous state?
For a large application, I strongly recommend a centralized state management pattern, like ngRx or Akita. The core idea is to treat the state as a single, immutable source of truth, instead of components modifying data directly, which leads to spaghetti state, where you don't know who changed what. Components dispatch actions.
Actions reduces effects, that's the standard flow, right?
Right. The action describes what happened. The reducer handles the synchronous state update. And for the asynchronous parts, like calling an API, we use effects. The effect listens for the action, makes the API call, and then dispatches a new action with the result. This makes the data flow predictable and unidirectional. It also makes debugging incredibly easy, because you can use the Redux dev tools to see every single state change, and even time travel back to a previous state.
How does that contrast with just using Angular's built-in routing and data provisioning?
Routing is great for what I call linear state. It manages the URL and tells the app which view to show. You can use resolvers to fetch data before a page loads, which is fine for simple apps. But routing only knows about the current path. A state machine like ngRx decouples the state from the URL. It can track complex relationships and user interactions across the entire app regardless of which page the user is on. Essentially, routing manages the where, while a state machine manages the what and the how of the data.
Let's talk about a performance issue I've seen in a few of our projects. We have some components that are recreating expensive objects on every single change detection cycle, which is slowing down the UI. What mechanism or pattern would you use to fix that?
That's a common issue, usually caused by calling a function or a getter directly in the template. Since Angular's default change detection is very aggressive, that function runs every time anything in the app changes. To fix this, the first thing I would do is switch the component to the onPush change detection strategy.
Why does onPush help?
Because with onPush, Angular only checks the component if it's at input properties chain, or if an event explicitly triggers a refresh. It stops the component from being reevaluated on every single global cycle.
But what if the expensive object still needs to be calculated based on an input?
In that case, I would move the calculation out of the template. I'd use the ngOnChanges lifecycle hook to detect when the input has actually changed, perform the expensive calculation there once, and store the result in a local variable. Then the template just binds to that variable. If the object is truly massive and used across the app, I might even move it into a singleton service to cache the result, so it's only computed once for the entire session.
That's a very professional approach. Let's circle back to lifecycle hooks for a moment. You've mentioned onDestroy and onChanges. What about onInit? Why use that instead of just putting everything in the constructor?
The constructor is for basic JavaScript class initialization, like dependency injection. But at the moment the constructor is called, Angular hasn't finished setting up the component's data-bound input properties. If you try to access and add input value in the constructor, it will be undefined. onInit is the first hook that runs after those inputs are available. That makes it the correct place to fetch data from a server, or set up initial variables that depend on the values passed down from a parent.
I think we've covered a lot of ground. To wrap things up, I've seen you mention mentoring juniors a few times. If you were to start a new project with a team of developers with varying skill levels, what are the first few Angular standards you would insist on?
First, I would insist on a strict state management strategy, whether it is a full Redux pattern or just a well-structured service layer, to prevent data inconsistency. Second, I would implement a strict rule about memory management. Every subscription must be handled via the async pipe or a take-until pattern. Third, I would set up a standardized project structure using the CLI and a shared component library to ensure we aren't duplicating effort. I believe that providing a clear, predictable A-frame for the juniors to work within is the best way to help them grow without them accidentally breaking the core architecture of the app.
I really appreciate the depth of your answers. You clearly have a strong grasp of not just the how, but the why behind these architectural decisions. That is exactly what we are looking for. I think we have everything we need for now.
Thank you very much. It was a pleasure discussing these topics with you. I look forward to hearing from you soon.
Thanks again. Have a great rest of your day.